Hello everyone, welcome to the IBM code pattern. Today I am demonstrating Engineering Insight composite pattern. This pattern is available at github.ibm.com IBM Engineering Insights composite pattern. As the name says, it's a composite pattern. Composite pattern means it's a combination of multiple individual code patterns. To demonstrate that, we have taken a problem in the domain of software development. In the software development, there are multiple types of artifacts which gets generated, like requirements, test cases, defects. So in a long running software projects, there are scenarios where these artifacts gets generated as an unstructured text. Now if question comes, what requirement relates to which defect, which test cases? Or what are the test cases I need to execute for a particular defect? As it is unstructured text, it is difficult to find out the answers of such questions. This composite pattern demonstrates a solution to such problems using a combination of other individual code patterns. Now, how are we solving this problem? What all code patterns we are using it? We will explain through a flow diagram. In this flow diagram, the center box shows the engineering insights process flow. We have document store here. We start with to extract the unstructured text content. After reading the unstructured text, we do the text classification. Text classification is achieved using Watson text classification pattern, which is available at developer.ibm.com/code/patterns/extend Watson text classification. This pattern uses Watson Natural Language Understanding API to extract the metadata from the text, which gets augmented with the text classification grammar provided in the configuration file and the Python NLTK module output. After the text classification, this output is given to the text correlation. For the text correlation, we are using Watson document correlation pattern. This pattern is available at developer.ibm.com/code/patterns/Watson document correlation. It uses the text classification output and compute the text similarity. It finds the relationship between entities and it calculates the scores. For a score, it uses the Python cosine similarity. Once we get all the keywords, entities, their relation, their related attributes, scores, we store all these information in OrientDB to get the more insights from it. For that, we uses the pattern of GraphDB Insights. The pattern is available at developer.ibm.com/code/patterns/store graph and derive insights from interconnected data. OrientDB is a multi-model database which supports Graph Database Engine. This pattern explains how to create classes and its attributes as in properties for all the entities, how to create edges for all the relationships among the entities, and also it tells how to query the database to get more insight. Once it is done, then we can query the OrientDB to get more insights from it. To visualize the data, we need one integration module for which we are using Orchestrate using Node-RED module. It is available at developer.ibm.com/code/patterns/orchestrate data science workflows using Node-RED. Using this pattern, we have designed one UI dashboard which invokes the OrientDB queries or the data science workflows to visualize the data. This pattern demonstrates an interactive user interface using D3, which allows an user to drill down to get more insights on the artifacts. Here are the steps given which we need to follow in sequence to achieve the same result. Once you have executed step 1 to step 10, then you are ready to analyze the results. How to analyze the result, I'll just show you through a demo. Before showing the demo, I will show you the sample data. It will give you the better understanding to visualize the results. Here we have created some of the requirements for a project. Related to these requirements, some defects have been created. And similarly, few test cases have been written for the same requirements. Now go back to the demo. Here in this notebook, I have started the WebSocket listener. It says that it is running. Now when we go to the Node-RED, it shows that socket is connected. Then we go to the URL. It will load the page. It will ask you what artifacts you want to see. So if I choose defects, it will show me all the defects. The defects, see, it will show the severity wise defects. Now here, if for a defect, if I want to see more relations, in the sense this, it shows defect to test case to the requirements. And if I just choose any of the defect, it will show me the relation of that. If I see this is the defect and it shows related test cases, from that test case it shows the related requirements. Here you can see that there are links that are in two colors. One is green and blue. Green color is like score 0.6 to 1. It means it's a highly related, and other ones are the less related. So we are just showing, and we have taken into consideration a score greater than 0.4. Now if I just see and I go here, it will show the score. It is having the 0.7 score of with this defect to test case TC120. Now when I go back, it will be showing me all the things. Now here I can see more insights into it. If, for example, if I just say get severity 1 defects, it will show me all severity 1 defects. If I say get defects with no associated test case, so there are chances that we do have such defects which have no related test cases. So if I just do that, I will get that. Now if I click on that, it will show me no related because we have find out the relationship in such a way defect to test case. If there is any related test case, then related requirements. Now similarly, if you want to find out test cases, you just search test case. Test case will give you all the FVT, SVT and TVT. Here we can get more insights, get all FVT tests, SVT, test cases with a zero defects. If I just choose any node, then it will show the related requirements. So it all depends on the text of the test case or the requirements, that how they are related, how the score is calculated using the cosine sim narrative. Now similarly, we will go for the requirement. It will show all the requirements here. P1, P2, P3 shows the priority. Now here we can go get requirement with zero defect. It will show is there any requirement which have does no related defect. Similarly, is there any requirement which does not have any related test case? It will show that. Show me the requirements which are having the greater than or equal to 5 defects or more defects. That number can be configured. Then it will show me those related requirements. So this is how we have designed the UI. Other than that interface, this solution can be enhanced through the following mechanism. This enhance sample config.txt, enhance the text similarity, like we can use the add lemmatization and the spell corrections techniques can be added into that, and add more insights into it. This is how we have achieved here in Engineering Insights a composite pattern. Thank you.